Here's 2018 question 3. Notice how there's no calculator active here, but that doesn't mean it's a difficult problem, okay? In some cases, or in most of these cases, it's actually a lot easier, okay? Here's a graph analysis problem here, okay? I right away understand that the graph represents G, and they do tell me that the function G is a piecewise function from -5 to 3, and after, from 3 to 6, that's actually a parabola right there, okay? So, here we go. Part A, if f of 1 is 3, what is the value of f of -5? What the heck is f, right? So if you read back a little bit more clearly, the graph of the function g is the derivative of the function f. So let me write that down over here. We know that g of x is equal to f prime of x. Okay, so a little bit sneaky, but here we go. If we want to go to just f from f prime, we're going to have to integrate this, okay? So I want to go ahead and integrate f prime of x. But remember, f prime of x is the same thing as g of x. So I'll write it out step by step for you guys. I'm going to integrate f prime of x dx, okay? But f prime of x is g of x, so that's the same thing. Okay? Just like that last problem we just did with particle motion, at the top, you're going to put what you want. So in this case, what I want is, I'll use a different color. I want -5, and what I'm given is 1. But I have to consider where I started at 1. I notice that f of 1 here is 3. Okay, you do that very often. You put down what you want, and you put down what you're given. And as always, you put down what you start with. Okay, so here we go. What does it mean? How do we keep going? What does it mean to integrate g from -5 or from 1 to -5, right? So first off, I want to flip that around because I like to work from left to right. You don't have to do it, but that's just a preference, okay? What does it mean to integrate? Okay, you're finding the area under the curve, specifically from -5 all the way to 1. So let me shade that for you here. It's from -5 all the way to 1. So notice how I have negative area here and positive area. So I have negative area here because it's below, and I have positive area here. So here at the bottom, you could cut this up into several pieces, or you could just see it as a trapezoid. Which is just 1/2 times the height. The height here is 3. And the sum of the two bases are going to be, that looks like 4, and that looks like 3. Okay, so if you clean that up, but you don't have to, I think that comes out to, let's see, 720, -21 over 2. Okay, over here you have a standard triangle, 1/2. The base is 1, the height is 2, so that comes out to +1. Okay, so that's just going to be -21 over 2 plus 1. You could have left it as bare as possible if you wanted to, but there you go. Equals equal. Okay, here's part B. They ask you guys to integrate g from 1 to 6. So nothing new here, except you're integrating g elsewhere. So we're integrating g from 1 to 6. So let me highlight that there. We're going from 1 to 6. So the issue with this is, if I go all the way up to about 3, I have a geometric shape that I know how to find the area of. That is just a, let me use a different color. That right there is just a square, which is base times height. The area there is going to be 2 times 2, which is 4, positive, okay? But the moment I surpass 3, this shaded region is not a geometric shape that I'm used to, which is why they gave you guys another function right about here. Okay, so they're making you do a little bit of work here, okay? So we know the first area in blue is going to be 4 plus. Okay, now how do I handle that yellow area? So how do you find area, right? We're going to have to integrate g again, but from 3 to 6. Okay, so since it's not a common geometric shape, we're actually going to have to approach this analytically. So we're going to take the integral from 3 to 6 of 2 times x minus 4 quantity squared dx there. Okay, so here some techniques. You could pull out that 2 right there, and we could just integrate the rest. Since x minus 4 is a simple linear, even though it's a function in a function, chain rule is not required. So you could just integrate this. This will come out to 2 quantity x minus 4 to the 3rd power over 3. And then we're going to integrate this from 3 to 6. Whether you guys decide to keep that 2 on the inside or the outside, it really doesn't matter here, okay? So all that's left is to just finish our integration there by evaluating. This is going to be 6 minus 4 cubed over 3 minus 3 minus 4 cubed over 3. And that's enough for equal is equal. You won't get any extra points. I encourage you guys to stop right there, okay? That's it for part B. Part C here. So from -5 to 6, so the whole graph on what open intervals is the graph of f both increasing and concave up. So they're talking about f, okay? So I'll write this down below here. We want f to increase and we want f to be concave up. Okay? So what I'm going to do here is, well, what does that tell me about f prime? Okay? F is increasing if f prime is positive. F is concave up if f prime is increasing. So the reason why I'm looking at f prime is because if you go back to this problem here, let me erase this so that there's room. At the very beginning, we were told that g is the derivative of f. So these two are equal. So going back to this, instead of f prime, I could just call this g. So I'm looking for where g is positive or above the x-axis, or when g is increasing. Okay, so let's go back to our picture here. I'll erase it so that we have room. Okay, so first I'll start off with where g is positive, okay? G is positive from here to here. Okay, not including the 4. And g is increasing literally from here to here, here to here, and here to here. Where does the yellow and the blue overlap, right? So it's looking like from 0 to 1 and from 4 to 6. And there you have it, okay? How do we know that? We're going to say since g is greater than 0 and g is increasing. Okay? I think the scoring guidelines have the same thing. Yeah, that looks good. They wrote it in a very complicated way, but that's pretty much all you need, okay? Here's part D, last one. Find the x-coordinate of each point of inflection for the graph of f, okay? So remember, f will have a POI, a point of inflection, if the second derivative changes signs, or if f prime changes directions, or if f changes concavity. Okay, so there's a lot to choose from here. Okay, so we have to use what we know. So we have the graph of g, okay? The graph of G is given. So notice here how G is equivalent to F prime. So let's use to our advantage F prime here. F prime, remember, is just G. So can we see where G is changing directions? Okay, when does G change directions? Okay, so it's looking like it's only changing directions at x equals 4. Okay, prior to that, it's either moving constant or going upwards. Okay, changes from decreasing to increasing. Okay, that's pretty much it. Okay, now the reason why we don't choose 3, which is what some people do, is you're not really changing a direction here. The particle is traveling upwards, stays still, and then goes downwards. Actually, I'm wondering why it doesn't have that. I don't know, but I don't want to go back and do my video again. But, when you watch this video and you still have a question, text me. I will probably have an answer by then. Okay? Thank you.